Hey, I'm Pat, and in this video I will be covering object-oriented programming in Roblox Studio. So, if you haven't already, I highly suggest you learn about meta tables and module scripts. I have videos on both of them already pretty much, but I'm gonna start getting into it already. So, the idea behind object-oriented programming, pretty much what it is the idea of using objects, and these objects will have different properties and functions and like behavior that you can use to pretty much control them. And their way of storing and managing data pretty much is the way of thinking about it. And you might be thinking this sounds a lot like instances in Roblox Studio, and you would be kind of correct, since object-oriented programming is very similar to how we have objects inside of Roblox Studio, like part, and it has a bunch of different properties, and this part also has functions and methods that we can call, like get touching parts is a method for a part. Parts necessarily don't have many methods, so it's kind of a bad example, but for example, a player would have a bunch of methods like kick. Alright, I'm picking some bad examples. Player service would have a bunch of methods like get player from character and get player from user ID, things like that. So basically what object-oriented programming is we'll be creating our own objects, which will be represented by tables using meta tables, and these objects we'll have different functions that we can use, as well as properties that we can manipulate to pretty much store them. If you can't think of like why this would be useful, think about things like a tycoon, where you would want to store per se an object that would contain the player's current tycoon, like the current upgrades it has, and you could have functions to upgrade the tycoon for different costs, like whenever they touch one of the upgrades or whatever. And you can store their current upgrades, you know, how much money is stored in the thing that is to be collected or whatever, right? If that makes sense. There's other use cases as well. Obviously there's a ton of use cases. Object-oriented programming gives you a lot of opportunity for making your scripts very modular, which is the idea that it's very easy to add on to it and it's very easy to modify. And that's the whole point of module scripts, obviously, is to make things very easy to modify, easy to add on to, easy to reuse. That's also a very good thing with object-oriented programming, is you can have one script for like an entire thing. Like for example, we want to have like a punching combat system. We could have a script that controls the punching combat system, but we can have multiple different styles of punching per se, with different animations and different damage and combos, but they could all be represented within one module script. And say each fighting style will have different properties, like it's different animation sets, different combo style, different damages. You know, you kind of get the idea, right? So that's kind of the idea behind it. So let's actually get into writing some code behind how it actually works and things like that. So the first line, you know, you're gonna need this, right? You're gonna need a table, because your module is going to be your meta table. So, and we're gonna do module underscore index equals module. So whenever the module or our object will be indexed, it will if the index is nil, it will index this table to check it. So pretty much our module is going to be holding all of our objects methods, which will be most of the functionality for our objects, right? So that's kind of how that works, and we're going to be using meta tables to manage that, which is very easy. And it makes it very easy to pretty much reference the module, if that makes sense. I'm not doing a very good job of explaining right now, but It's alright. So next thing we're going to do is we're going to need a function, and this is going to be our constructor function actually. And what a constructor is I don't know how much I've gone over constructors. I don't think I really have, but we have a bunch of constructors like color3.new, udim2.new, vector3.new, cframe.new. Those are all constructors, and what they do is they pretty much create a new object. So cframe.new will return a new cframe with the given arguments, and vector3.new will return a vector3 with the given arguments. So we're going to need our object, a way of creating our object, and that is usually called the constructor method. This is more of a function. We could also use this, the colon, which will make this a method. And the whole reason, I guess I won't go too into that right now, but yeah, so a constructor, what it does is it will create a new object, and it will return that object so we could use that object in our code. So the way we're going to create our object is what we're going to do is local self. Now this could actually be anything. This could be a fake table like this. Like, you can make this variable anything, right? But for this instance, I'm going to use the keyword self, and the reason for this is because self is representing the current object. Lua has like this built-in keyword self, and self pretty much just represents the object. And the way self works is whenever a method is called, self is automatically passed to it. So for instance, if we were to do, let me open up in our script, local works, or let's just do workspace, get children. What it'd do is it actually pass workspace as self. So workspace would be stored in self automatically. We don't need to pass any extra arguments through the arguments list. The script knows that it's passing the object that the method is being called on. So it's calling the method on workspace. The method belongs to workspace, right? So it knows that self is going to be workspace, if that makes sense. So we're using module new, so it knows the self is going to be module, but usually if you use .new, you're going to have to do local self because self isn't passed. Or you could just have self in the arguments, but that doesn't really make sense for a constructor. So in this case, what I'm going to use is a colon. I know a lot of people hate doing this, but it's something I'm very used to as a constructor like this, so it's how I'm going to do it. You can do it kind of however you want. There's 20 different ways to make a constructor, but this is how I'm going to do it. So we don't need to define self here because it's automatically passed through the colon. However, we are going to be changing the value of self because we obviously don't want to use our module script. We want to use we want to create a new table for our object. So what we're going to do is we're going to use set meta table, and we're going to give it an empty table, and we're going to use our module as the meta table, obviously, because we want to use the index meta method here. So that pretty much creates us a new object or a new table, and it's going to be using all of this module's functions in it. So it's going to be inheriting, if you will. If you think about inheriting as in like you inheriting your father's watch when he passes away or something like that, right? You inherit it. It's kind of similar where this table is now inheriting this module. That's kind of a better way of explaining how a meta table works, kind of. If that makes sense to you, I don't know. Inheriting may not be a word that you're very familiar with if you don't know object-oriented programming, but it's fine. So, next thing, we can just return self here, and that is usually what you're going to want to do, is you're going to want to return your meta table that was set. You're going to want to return it so it can be used. Maybe in other cases you might just, instead of returning self, you might actually store self inside of a module script so it can easily be accessed by other scripts and reused. But you might want to return it so the script itself can manipulate it and do what it wants with it. But now what we can do is we can give our object properties. So the way we're going to do this is self dot, and then we could do it multiple ways, right? We could give it properties inside this table, which would be just a bunch of key values, or we could do self. Say, what kind of module object should we make? I didn't think of a good module to make. Alright, for example, I'll just use like a punching system, even though it's not going to be fully functional. We're just going to use that for example. So for a punching system, obviously for one of the properties, it's going to be damage, or maybe base damage equals 10. Now, obviously in your new constructor, what you'd want to do is pass all of your arguments for your object to make that object different from all the other objects, to kind of make it special, right? That's kind of the idea how a constructor works. Like vector3.new, you give it 3 different coordinate values for your position. Same thing for like cframe.new, right? So what we'll do is we'll make our first parameter base damage, which we will then set to we'll set the object space damage to the past base damage pretty much, and then combo count, I guess, will be your next one. Self dot max combo equals combo count. So obviously this will be like how many punches it'll take to reach like your final attack or your max combo before it resets or whatever, right? So like after 3 punches you go back to like the first animation, then you go back up, whatever. And then we could have maybe a damage multiplier, and the damage can multiply for each combo. So obviously, so this kind of makes sense, right? We're gonna create a new fighting style. It's going to have its own base damage, which we're passing. It's going to have its own combo count, which we are passing to it as well. It's also going to have its own damage multiplier based on, you know, the combo count, which we are also passing to it, right? And then we're going to return the object so it then can be used inside our script. So what we'll call this is fighting style handler, something like that. FSH, we'll call it that for short. Require script.parent, a fighting style handler. So now we got our module. Now all we gotta do is we just gotta create a new object. So local new style. We can actually call this like kickboxing maybe. And then we can do FSH dot, or not dot, we have, now you can actually do dot new, but then you would have to actually pass FSH because it needs a self variable, right? But in this case, it doesn't matter. We're going to use the colon new, and you can see it actually tells you the parameters that it needs. So it says combo count, damage multiplier, and base damage. So we're going to give it a base damage of maybe 5, combo count of 3, and its damage multiplier will be like 1.1 maybe. So now what we got is a kickboxing fighting style, and now we can't actually do anything with it. So in this case, we're just going to print it out real quick just to show you what it looks like. And I'll go ahead and test run it real quick so we can see more of a visual of what really is happening here. So we run it. We got base damage 5, damage multiplier, max combo. It's not in order because it's a dictionary, right? But that's kind of how it works. So we got a bunch of properties. Now what we need to do is give our object some actual functionality. Something that maybe has some more meaning to it. So what we'll do now is we'll give it a punch function maybe. So module, or we'll give it an attack. Because in our fighting style we might have punches or kicks, and we're actually doing kickboxing here, so kicking is more necessary, even though kickboxing, you know, I'm not even gonna get into it, it doesn't matter. So we're gonna do module attack, and this isn't gonna actually need any arguments. Now you can see we're using the colon here as well. Now you could use a dot right? But then you're going to actually need to get the self object in here, because you do need a object here for something like this, because you're going to need to maybe use the object's properties, or you're going to maybe need to change them or something like that. So it's very important that you have access to the object. You can't just do self, because it won't immediately know what self is unless you're using maybe a colon, where it'll automatically pass the object over, if that makes sense. So then what we can do is, actually I'm going to give our object another property called current combo, and we're going to set it to 1. So then what we are going to do is we're going to print out how much damage we do based on the combo that we have. So we'll do self. Now you'll notice that it doesn't know what self is here, because it's not sure what is being passed as self in this case, but we can give it something like this, like current combo is actually more appropriate. Current combo, we'll print out current combo times self.damage multiplier, and that will be how much damage we're doing for that attack, pretty much. Then what we'll do is we'll increment our current combo. Now you'll see Roblox knows that self theoretically has a current combo index, so it's going to autofill for us. And we'll plus equal it to 1, and then we'll check to see if self.current combo is greater than self.max combo. Oh wait, I did this wrong, didn't I? Should be more like, how would I want to handle this? Yeah, we could do it like this. So what we'll do is we'll multiply the current combo by our damage multiplier, and then we'll multiply it by the base damage to get our total damage output. Even though that's not really, like, I don't think that's a very good way of handling it, but we're not trying to make like a amazing combat system or anything. So what we're doing here is we're checking to see if we're over the current combo, and if we are, then we'll set self.current combo back to 1. So if we reach our maximum combo, then we'll go back to our first combo. Now what we can do is make a for loop. Maybe we'll do 5 do kickboxing attack, and we'll call the attack 5 times, and we'll see what it prints out. So you'll see we get 5.5, 11, 16.5, and then once it reaches it, that's its final attack right there. It goes back to 5.5 and then 11 for the second attack, right? Now what we could have is theoretically a second fighting style with different properties that will be handled in a different way. So say now we want to have a base damage of 7, maybe give it a combo of 4, and this one maybe we'll give it a little bit less of a damage multiplier. This could be Thai, maybe Muay Thai, if you want to do it like that. And after that, what we'll do is we'll print kickboxing, and then we'll have a way of separating it. Maybe give it some scores like this. Thai. Alright, there we go. So we got our Thai and kickboxing, and we're going to do 5 kickboxing attacks, and then we'll do 5 Thai attacks, whatever. So you get the idea. So we got kickboxing, and you know, it increments slowly. This looks like some kind of weird number error, some kind of floating point error. This is kind of weird, but you can see Thai 1, 2, 3, 4. After 4 attacks, it goes back, and they're both separate. So we got completely separate fighting styles with different properties, different combo styles, different damage. So we could use it like this, and it makes it very easy, because say we want to change how the fighting styles are handled, we can change you know, the way damage is handled right here pretty easily. It's just one script. We just go on this one script and change how damage is handled. Or say we want to change how combos are handled. We only want to increment the combo if we successfully land the attack. Then we could easily do that inside of here, right? Or say we wanted to add something like evasion, like a player has a chance of dodging when somebody tries to hit them. We could add that in here very easily. We don't have to go through like 20 different scripts for each fighting style and change each fighting style to implement our evasion or change how we handle damage and all that, right? It's just one script, simple, very easy to modify. You can even add comments, maybe make it a little bit more simpler. This is the whole idea behind object-oriented programming. You can use it in so many different ways. You can use it for combat systems, you can use it for tycoons, you can use it for controlling your players' data, like you know, like their skins and maybe their currency. Like maybe you want to have a way of adding currency, and once you add that currency, you could fire it to the client and tell the client to update the GUI to display the new currency. So you can always call that function to pretty much add currency. Or maybe you want to give your player an XP modifier, so whenever they gain XP, it's multiplied by their own XP modifier, and then it's replicated to the client through a remote event. You could do that with object-oriented programming, right? You could give them a property under self, which could be their XP modifier. You could also give them their current XP, like their goal XP and their level, and you can have a method for gaining XP, and that XP could be given to the player based off of their XP modifier, and then you'd want to fire to the client to maybe update GUI to display their maybe their new level or their new XP amount, whatever, right? Now thinking about that, you could even make that right now if you wanted to, as for like a practice thing for object-oriented programming. Hopefully this made sense. I know object-oriented programming can be kind of tricky for some people to figure out, but once you get the hang of it, it can be pretty useful. A lot of people like to overuse it, but I think it's a very powerful thing. It's kind of what I'm very used to is object-oriented programming. So hopefully it makes sense, and learning object-oriented programming will really help you understand how Studio itself works as a whole, because it somewhat has object-oriented programming traits as far as how instances work with inheritance and things like that. And honestly, I'm going to be going over inheritance in my next video probably. Object-oriented programming is obviously not only limited to this. There's a little bit more that I'd like to go over more in depth, so I'm planning on going over that, but this is more of a simple overview of how object-oriented programming really works. So hopefully this helped you out. I recommend getting in some practice with object-oriented programming. Maybe try and make an XP system, just like I said, or a currency system, or try and make a tycoon with it, or fighting style like we showed, or maybe a gun system. You know, there's like so much you could do with it. A lot of people say they struggle finding a use case for it, but I feel like it's not that hard if you just think about it. But yeah, that's pretty much it for this video. I don't want to make it too long, but yeah, that's it. Hopefully this helped. Thanks for watching.